What's up, everybody? Welcome back. Patrick here, moving on to another communication question. There's going to be parts of this question that are going to be fairly difficult, fairly unique, that we didn't even cover in the lecture videos. So just brace yourself for this one. So the following rational expression is the product of two other rational expressions. Write what the two rational expressions might have been. What if it was a sum of two other rational expressions that had different denominators? So there's two parts to this question. We basically have to find two rational expressions. So these represent like fractions, numerator over denominator, numerator over denominator. So the first part of the question is saying that two rational expressions are being multiplied by each other. And you end up with this here. So they're asking what could have been the two rational expressions. There's actually multiple infinite answers here. And then the second part of the question is you have these two rational expressions that you're adding, the sum of two other rational expressions. And we have to get this as well. Right? So this is going to be like the first part of the question. This is the second part of the question. And this second part here is going to be a lot more difficult than this one. Just as a heads up, it's going to take quite a bit of explaining, but I'm going to do my best. Okay, so starting off with number one, we're taking two rational expressions, multiplying them, and they have to equal this here. This has to be our final answer. So when you get a final answer, you want to make sure everything is factored first. So we got 3 over x squared minus x minus 2. Well, this is the same as 3 over what? When we factor this, this would be x minus 2, x plus 1. Right? So let's erase this and just focus on this here. So what two rational expressions multiplied by each other would give us this? Well, how about x minus 2? Let's put a 3 up here, and then let's put a 1 up here, and then x plus 1. That works out, right? 3 over x minus 2 times 1 over x plus 1. You just multiply the numerators, multiply the denominators. You would end up with this. There's no other factors that could cancel out. Now, let's say you do want to add factors that would cancel out. Well, we can maybe, let's say, add an x plus 3 here, and then we can add an x plus 3 up there. So instead of 1, it'd be x plus 3 over x plus 1. This would be 3 over x plus 3 over x minus 2. The x plus 3's would cancel out, and you would end up with that as well. Or you can maybe add a factor here, maybe x plus 4, and then maybe add an x plus 4 down here. Right? So there's infinite amount of solutions. You can add an exponent, right? They would still cancel out. But if you want the most simple answer, I feel like this here would be it, the one that we had initially. So having the 1 over x plus 1, and then this is gone. But again, there's infinite amount of solutions. Thought I would show you a couple of different examples. And you could have also put the 3 here, right? So it could have been 3 over x plus 1 times 1 over x minus 2. You would still get that same answer. Right? So that is the answer to the first part. What about the second part? What if you're adding two rational expressions? Well, if you're adding two rational expressions, it's going to be a lot more difficult to find what that numerator is going to be initially. Because notice we can't just add 3 and 1, or let's say we change this to a 2. We can't just add 2 and 1 and get 3 because these are not common denominators. That common denominator is going to be these two factors multiplied. All right? So how can we figure out what the expressions are in the numerators? So this is fairly difficult. What you want to do, what I would do, you could do it by trial and error, but if you actually want to figure out what it is, you could put an A there and a B here as variables that you would solve for. And then you would have to actually go through solving this. So what would be the lowest common denominator between these two? Well, we would just multiply these like that. So notice we have the same denominator already. But this x minus 2, we multiplied by what to get this? We multiplied by x plus 1. It means we have to multiply the top by x plus 1. So we would have a bracket x plus 1. And then here, this x plus 1, we're multiplying by x minus 2. So this, we're multiplying by x minus 2. So this b, we would multiply by x minus 2, like that. Now what you do, here's where it gets a little bit weird. You want to expand in the brackets. So we would have ax plus a plus bx minus 2b. And this would be all over x minus 2 over x plus 1. And actually, I'm going to continue this up here. Okay, then what you want to do is you want to put the expressions that have an x attached to it together in the front, and then the rest of the expressions, so the a and the minus 2b in the back. So we would rewrite this as ax plus bx plus a minus 2b, and this would be all over x minus 2, x plus 1. Okay, and now from here what you do is you just factor out an x from these two. And let's put it in front. So we would have a plus b times x, and this here we would just keep as a minus 2b. And this would be x minus 2, x plus 1. Okay, and here's where it gets, it's already been getting weird, but it's still going to keep getting more weird. It's a fairly difficult question. Now, what are we trying to get to? We're trying to get to 3 over x minus 2, x plus 1. Right? We're trying to get to, I erased it, but that's what it was initially. So notice that there's no x variable up top. All right, so what that means is that a plus b has to equal 0, right? Why? Because if a plus b is 0, this whole bracket is 0, and 0 times x is 0, so we would get rid of the x, which is what we want because there's no x in what we're trying to get to, right? So we want this part to go away. We just want to get a constant of 3 up top. So a plus b has to equal 0 in order to get rid of that x there. And then a minus 2b has to equal 3, right? The remaining expressions, these are just constants. A minus 2b has to equal 3, what we're trying to get to. And if basically both of these are satisfied, then we're going to end up with having a 3 in the numerator. Now, what if we were trying to get to, let's say, 2x plus 3 instead? Well, then a plus b would have to equal 2, because there would have to be a 2 in front of the x. So this would change to a 2. And then a minus 2b would still be 3, because that's the constant we're trying to go for. And then the a minus 2b is a constant. But there is no x in this case, so a plus b has to equal 0. Okay, hopefully that makes sense. It's a little bit complex, a little bit unique, but that's how I feel is the best way to solve what those constants would be up top if you're adding rational expressions and trying to get to a certain rational expression. It's a very tough question. Multiplying, again, it's easier because you don't have to worry about this lowest common denominator and then the numerator is changing. You just multiply everything, cross stuff out, and you just have to get to something. But here, this is more of a complex puzzle that you have to put in this format. Got to get rid of the x, so a plus b is 0, and then a minus 2b has to equal 3. And notice here, we just have 2 unknowns and 2 equations, so we could solve for a and b with substitution or elimination. So bringing those up here, we got a plus b equals 0, and then we got a minus 2b is equal to 3. I say we isolate for a here, so a would be negative b, and then plug in negative b for this a, so we'd have negative b minus 2b equals 3. These are like terms. Negative 3b is equal to 3. Divide both sides by negative 3 to get the b by itself. B is negative 1. All right, so if b is negative 1, it means a is positive 1. So those are the answers, actually. So if we rewrote this, a over x minus 2, we would have 1 over x minus 2. And then b is negative, so this would be like negative 1 over x plus 1. There's like a plus here. And then this negative and this positive, we could change to minus like that. And that has to equal 3. That will equal 3 over x plus 2, x plus 1. Right? And these are pretty nice answers, 1 and negative 1, but they're not always going to just be 1. They could be any constant. But yeah, that's how you do it for the sum. Fairly difficult and a little bit unique, something we haven't really discussed. Usually teachers just throw the multiplication or division of rational expressions on a test and give you the answer and ask you what the originals were. Very rarely they'll ask you for the sum, but if they do, this is how you do it. One more thing I want to mention before finishing off the video is that you can actually check your answer. So you can actually take this here and then solve it on the side, get a common denominator, multiply this numerator, simplify the numerator, and see if you actually get what you're trying to accomplish, what you're trying to get to. And you would see that if you actually do this, it would, in fact, equal that. That's when you can be confident that you got the right answer.